Hi, my name is Michael Murtaugh. I am a professor at the University of Minnesota. I've been studying immunology and molecular biology of the pig, so we are interested in understanding how pigs respond to infection and how they resist disease. I've been working on PRRS for more than 20 years, both trying to understand the virus and how it is changing and evolving and how pigs respond to it, where the expectation is that knowing about immunity to PRRS virus will help us develop better, improved vaccines. Vaccines work by inducing a state of protection in pigs so that if virus is seen again, they will be able to resist infection. So vaccines are made from one strain of the virus. It's essential that vaccines provide cross protection because there is enormous genetic diversity in PRRS virus. So the exposure to field viruses is always going to be different than the exposure of the pig to the vaccine virus itself. So people look at cross protection in two ways. One is in the respiratory disease form of the disease, where cross protection is tested in young growing pigs. And there are many studies, probably more than 20 studies done to look at protection of vaccine against various challenge viruses, and they always show substantial cross protection against respiratory disease. The other disease of PRRS in pigs is the reproductive disease in pregnant sows, and again, cross protection is always observed here as well. And cross protection is not only identified in tests done in the US, cross protection is also seen substantial cross protection against high-path PRRS in China. Adjuvants and the ability to potentially improve modified live vaccines is a very interesting question. Adjuvants were discovered and developed based on their ability to take things that were not very immunogenic by themselves and make them potent, strong antigens. So the way that this has been used in making vaccines has been applied to taking bacteria or viruses which, while they're able to induce good immunity, they also cause disease. The challenge is to have something that induces immunity without disease. So you can avoid disease by killing or inactivating the virus. But when you do that, you usually lose immunogenicity, or the ability to be a strong antigen. Adjuvants recover some of this. They are a way of taking dead antigens and making them look like they're live. Now, in the case of modified live virus in PRRS, this is a live replicating virus. Adjuvants are not expected to have a benefit because the virus is already growing. It's been attenuated, so it's already safe. So there's no need to have an adjuvant. In the case of PRRS, people have tried to figure out how to make the response to vaccine stronger. And while not using adjuvants, because adjuvants are things that by themselves do not do anything, they make something else work better. There's no evidence that in this application you can improve PRRS vaccines. But maybe you could make vaccines work better if you boosted the live virus with a little bit more protein, say the membrane protein of the virus, or more dead virus, and might boost the response. And many people have tried to use these approaches, not adjuvants, but boosts to immunity. And no one has been able to demonstrate reproducibly and with any field efficacy that anything can work better than modified live virus vaccine by itself. No, in the case of PRRS virus, I do not think the adjuvants could have an impact on cell-mediated immune response to PRRS. The most adjuvants that have an effect usually are measured in antibody responses, but again, we see no evidence that the cell-mediated immune response or cross-protection against other virulent virus challenges can be made to work better than what the response you get just by live modified virus by itself. The question if maternally derived antibodies from sows affect the efficacy of piglet vaccination is a really important question, but really surprisingly it hasn't actually been addressed until just recently. But in the absence of experimental studies and investigations, we have some field indications based on the common vaccination of piglets at weaning at 3 or 4 weeks of age and the well-demonstrated ability of those vaccinated pigs to be protected from PRRS in the nursery and in finishers. This says that whether maternally derived antibodies are present or not, or have a beneficial or negative effect, the practical impact is not important when vaccination is given at 3 or 4 weeks of age. Another indication is when people have asked if they could vaccinate at 1 week of age or at processing, which commonly is at 3 to 5 days of age. And people have observed here that vaccine applied at 1 week of age does not provide as good protection in the nursery and finisher as does vaccination at weaning. Since these studies have been carried out in herds that are PRRS negative and in PRRS positive, it suggests that the vaccination early in life at 1 week of age doesn't work as well because the immune system is not developed, not because maternally derived antibodies are interfering with the efficacy of the vaccine. I do not think that using different strains of vaccine virus in sows compared to piglets would have a significant benefit on vaccine efficacy in piglets. One of our observations over many years and the clear demonstration of good cross protection where pigs that see one virus are substantially immune to any other virus they see. So if you have immune animals and you give another virus, the same or different virus, in most cases the existing immune response will prevent infection by the vaccine virus, and so there will be no boost or no enhancement of immunity. Nearly everything that we know about immunity to PRRS virus suggests that one good vaccine will work in the majority of cases, and the ability to enhance immune responses by using different vaccines in combination or different vaccines in sows versus piglets, for example, will not have a large benefit. So with respect to whole herd vaccination, how important is it to use the same or different strains in vaccinating sows and piglets? Again, this is a really important question. The vaccine that you need to use is one that's both safe and effective. And if you have 2 modified live vaccines that are known to be safe and effective, it might make sense to use them, one for sows and one for pigs or piglets. But the reality is today that there's only one vaccine, the Behringer's MLV vaccine, that had been widely tested in the field and known to be highly safe and highly efficacious against a wide variety of field isolates. And using the same vaccine in piglets and sows has been demonstrated to be highly effective. So again, while theory might say that this practice of using different vaccines could be all right, in practice, there's only one option and one vaccine which is known and demonstrated to work well.